Hello, and thank you for joining me for today's lesson on power. So this will wrap up our work, energy, and power unit. So we're going to do a quick lesson on power that you kind of started. So to start with, power scientifically is a quantity that measures the rate at which work is done or energy is transferred. So power is going to be equal to work divided by time is going to be your equation. Now, we have a couple different things we can do with this, and we have a couple different ways we can look at this equation in terms of force and speed. So, for example, we know that power is work divided by time. We know that work equals force times distance. So we can substitute this into the equation, and we can get power equals force times distance divided by time. And now if I have that, so I have work equals force times distance all divided by t. If I look at just this section, I see distance divided by time. Hey, we've seen that before. That's our velocity equation. And so I can also have force or power equals force times speed, or force times velocity. So all of those are ways we can express power. Power is measured in watts. So remember, work is in joules. But because it's work divided by time, it's 1 joule per second is the same as 1 watt. So we have watts equal to joules per second. And joules, if you remember, is force times distance, which is newtons times meters per second. Well, a newton is a kilogram times meters per second squared, and then times meters, all divided by seconds. So this would together would be kilogram times meters squared per second cubed. So 100, there's not 100. There's a lot of different ways we can write and express our units. This is showing you all of, or the ones that we're going to kind of look at and use. So these are all possibilities for power. And then more commonly, we use what's called horsepower. So think of cars. 1 horsepower is the same as 746 watts. So if you had 60 watt light bulbs and you wanted to get up to 1 horsepower worth of light bulbs, you would need 12.4 or 13 light bulbs all running at the same time would be the same as 1 horsepower worth of power. Alright, let's do some practice. So first one says a 193 kilogram curtain needs to be raised 7.5 meters at a constant speed in as close to 5.0 seconds as possible. The power ratings for 3 motors are listed as 1.0 kilowatts, 3.5 kilowatts, and 5.5 kilowatts. Which motor is best for the job? So we're trying to find which number we can get closest to. So things I know. 1, I know the mass is equal to 193 kilograms. I know the distance is 7.5 meters. I know my time is 5.0 seconds. Okay, I have a mass, a distance, and a time. Power again is equal to work divided by time, which we said work was equal to force times distance divided by time. And we also know that force is equal to mass times acceleration. So we can have mass times acceleration times distance all divided by time. In this case, I'm looking for power. I have a mass, I have a distance, I have a time. Let's use this one, which is just this all written out. So I can solve for power. My acceleration, because I'm going up, needs to be raised. This is really important. And because it's raised at a constant speed, my force up has to equal my force down, which is due to gravity. So I know that my A is going to be 9.81 meters per second squared. So now if I plug this into power, equals my mass is 183 kilograms. My acceleration we said was 9.81 meters per second squared. And my distance is 7.5 meters. And all of this is wanting to be done in as close to 5.0 seconds as possible. So I'm going to take a calculator and I'm going to use 193 times 9.81 times 7.5 and divide that by 5, and I'm going to get an answer of 14. That's not right. Oh. I'm going to get an answer of 2,839.9. So 2,840 is going to be my power. I forgot to divide by my time initially. I was like, that's a lot. So we're going to get 2,000 840, and power is measured in watts. Okay, so I have a 1 kilowatt, a 3.5 kilowatt, and a 5.5 kilowatt. This number is going to be closest to my 3.5, so that's going to be the motor that I want to use. Alright, there's your practice. Here's a couple for you to try. So again, I'm going to give you a question such as this. I'm going to have you pause your screen, work through it, then I'm going to give you your answer so you can check yourself. But you have a 1 times 10 to the third kilogram elevator carries a maximum load of 800 kilograms. A frictional force of 4 times 10 to the third newtons retards or slows the elevator's motion upward. What is the minimum power in kilowatts that the motor must deliver to lift the fully loaded elevator at a constant speed of 3.0 meters per second? So work through that, pause this screen, and then when you come back, I'll give you your answer. Okay, your answer should come out to 65 kilowatts. This one's kind of tricky. You got to do a couple different things with it. So if you got stuck and didn't get that, come see me. We'll talk it through and we'll kind of work through it together. Here's another practice question. So a rain cloud contains 2.66 times 10 to the 7th kilograms of water vapor. How long would it take for a 2.00 kilowatt pump to raise the same amount of water to the cloud's altitude of 2.00 kilometers? Work through this one. Pause the screen. And here's your answer. It should take 2.61 times 10 to the 8th, or 261 million seconds, which is the same as roughly 8.27 or 8.3 years. And one last question for you. A couple questions actually. A 1.50 times 10 to the third kilogram car accelerates uniformly from rest to 10.0 meters per second in 3 seconds. What is the work done on the car in this time interval, and how much power is delivered by the engine over this same amount of time? So again, pause this, work through it, and check yourself. And here are your answers. That's today's lesson on power. We'll do some more practice in class. And thank you for taking the time to do this, and I look forward to seeing you later.